Hello and welcome to this week's Easy 11 Plus live lesson with a very agitated cat. He really hates appearing on YouTube. I'm sure he loves you, but he's not very keen on appearing up front. Oh, he's seen Gree. He's going to be off in a second. Anyway, fantastic to see you all here for this. There he goes. For this week's lesson on 11 Plus Maths, but as I've been doing every week recently, a little announcement about English. Don't forget that you can send me your writing for a completely free assessment, if you haven't sent work to me before, as a way of trying out my marking service. But you can do it without any commitment to sign up for anything. If you want to find out more information, I'll be posting a link in the comments straight after I've done this live lesson. But also there's a link in the video description, or you can just go to the 11 Plus Lifeline webpage and click on the link there for the free marking offer. The comments are coming in at last. Hi Robert Timegraph Lomax says vibes. Not actually my middle name. Other people will know what my middle name is, but it's always good to have a name. Swapna says, hi, Mr. Robert, my first time here. Swapna, I'm sorry if I haven't pronounced it right. It's wonderful to see you, and I hope you find this lesson useful. And lots of comments, lots of nice comments about the cats, about spelling, about people who are saying they watch videos and found them useful. I'm sure there are other people not commenting who watch my videos and thought, why am I doing this? Why do my parents make me suffer this torment? And I'm very sorry if that's you. Anyway, enough of all that. Keep the comments coming in, but I'm going to get started because there's quite a few questions here to give a good overview of how time graph questions tend to work in the 11 Plus and some of the different kinds of questions that you might see. So we're starting with a question. I'm going squeaky. We are starting with a question that's relatively straightforward as these go, but it's a nice way to introduce the concepts. And basically, once you understand the graphs and what they tend to be showing you and how to interpret them, these sorts of questions become easy. But you have to get that understanding first of all. And by the way, this is something that I have touched on in at least one other video. And in fact, if you go into the worksheet, for those who don't know, the worksheet for every lesson is sent out to people on my mailing list a few days before, and it's posted on Facebook, but also, crucially, it's linked in the video description, which is down here on YouTube and up there on Facebook. Okay, right, anyway, into the questions. So we've got Alan, and Alan climbs to the top of a mountain one day during his holiday. Below is a graph showing his height above sea level at different times during the day. So we know he climbs a mountain. The stuff about holiday is not relevant to us. This is a graph showing his height above sea level at different times during the day. So let's have a look at this and just think about it for a second in the way that I recommend you do before you answer a question like this. First of all, you look at the axis labels. So height above sea level in meters. So that's what this shows. So you've got 100 meters up to 900 meters. And we can see that, for example, at the start of the walk, presumably, he's at 100 meters. And he also ends at 100 meters. So this implies to me that the base of the mountain starts at 100 meters above sea level, which is the kind of thing you might well expect, because most mountains are in mountainous regions which are in themselves somewhat elevated, and so the starting point is not normally no meters above sea level. And as we go through the day, he is higher and higher above sea level. In other words, he's climbing a mountain. The highest point he reaches is this. Now, what does that mean? Well, the question explicitly says that he climbs to the top of a mountain. So if he climbs to the top, and this is his highest point, then this height must be the top. What height is it? Well, you just read across in a straight line. It's 800 meters. Okay? You can do that with a ruler in the exam. It's a bit hard for me to do that on my shiny screen. And I'm lazy. And also we've got these nice helpful guidelines on the graph to help us. And then he climbs down the mountain and there's a pause and he climbs down some more. How can we tell there's a pause? Simple. His height does not change for this period. So that strongly implies a pause. Now, it could have other meanings because this line is not showing us his distance. It's just showing us his height. So this flat bit could be that there's a flat part of his route. For example, maybe he's walking around the side of the mountain, and so he's still moving but just not going down. We can't be completely certain. Okay, so that's the kind of thought process it's worth having about something like this before you get into it, because now we understand what's going on here and we're in a position to answer the questions. Zakaria says, bro, this is so easy. Well, hey, bro. Bro, it doesn't really sound right on my lips. I'm sure it sounds brilliant on yours. Yeah, I mean, if a question is easy, that's fantastic. Then you know how to do it. I've chosen an easy question to start with, a relatively easy question, so that I can focus on explaining the graph in the way that I've done for people who aren't so familiar with these things. There are some slightly trickier things coming up, but I would say that nothing in this lesson is supremely difficult. It's not one of my very difficult maths lessons. It's kind of core knowledge in a way. How many meters above sea level is he at 11 a.m? So we got the time along here. Oops, I forgot to comment on that before, but hopefully that's obvious. So 11 a.m. is here. So we go up the line here and we come to this point here. Then we go across here and we can see that he is 600 meters above sea level. We need to check the units already there. They are, so we don't need to write meters, but you always need to do that check because often they aren't given. And if they aren't given and you don't write them, you will probably lose marks. Okay, because then it could be 600 centimeters, 600 kilometers, whatever. If I were to be pedantic, I'd say the question says how many meters, so it's in the question, so even a raw number should be okay. But always put the units unless they're given to you. At what time does he first reach 200 meters above sea level? Okay, because I've got this magic rubbing device, I'm going to make some space. 200 meters. So now we're looking at the height, meters. 200 is here. We go across, it's there. We go down, it's here. What is that? It's halfway between 9 a.m. and 10 a.m. Do we call that 9.5 a.m? We don't, not unless we want to lose marks. It's 9:30 a.m. Now, if you do not write a.m, you could lose a mark because this graph includes both AM times and PM times. In other words, it includes the morning and the afternoon. So if you say 9:30, then that could be 9:30 in the evening. So to avoid any risk, it's very important to write AM or PM. We're not working in the 24-hour clock here, so that difference is important. Okay. How many meters above sea level is the top of the mountain? We covered this already. He climbs to the top. This is his highest point, so that must be the top, and it's 800 meters. We did that when I was explaining it. So you see that time thinking through the chart is not wasted. Between which times does he stop on the way down? Well, we spoke about this before. There's actually nothing to prove that he stops, except for the fact that the question tells us that he does. So he definitely isn't stopping here because he's going down continuously. He's not stopping here and he's not stopping here because you can't stop while you're continuing to descend. The only point he could be stopping is here, so that's where it must be. Okay, so we now know from the question that he isn't walking around the mountain without descending at that point. So that's between 12:30 and 1. Okay, so we are not told AM or PM, so we need to include them. So we need to put 12:30 PM and 1 PM. Simple. You could say 12:30 and 1300, but that's unnecessarily complex, and it might be slightly annoying for the examiner with their mark scheme if they don't want to think by this point, because their mark scheme will be in the 12-hour clock, just as everything else is in this question. Give a sensible suggestion for why he might have stopped at this time. Why might he stop between 12:30 and 1 PM? Is it because he really wants to watch the Premiership football, or is it possibly to eat lunch? I wonder. Okay, on to the next. This is the graph of a firework rocket showing its height at different times. Okay? Now this might look like a map of its path. But of course the rocket, for all we know, just goes straight up and down. But the fact is that over time it gets higher and then gets lower. So there's nothing here about the distance it travels from its starting point, or horizontal distance. It's all about height, vertical distance. And what can we see happening? We've got the height here, we've got the time here. We can see that as time passes it goes up, so it starts going up very steeply. And as time passes it goes up less and less steeply until, it doesn't pause at the top, but for an instantaneous moment it is still, for an infinitely short moment probably, and then it starts to come down. Why is there this curve? Why doesn't the chart just look like this and this? Well, it's the effect of gravity, isn't it? Also air resistance, but mainly gravity, I think. In other words, as it goes up, it gains height less rapidly. With a rocket, that isn't necessarily the case. It could, in fact, gain height faster and faster until you know, as the rocket fires, and then as the rocket cuts, it slows, and then it comes down. There are various, you know, it comes down, then probably comes down something like this, getting faster and faster as it descends. So I think actually this shape on the left is maybe a more likely trajectory because it's powered upwards by the rocket engine. But what we've got, could you call it an engine on a rocket? I don't know. Probably. By the combustion of the rocket fuel, let's say that and avoid any mistakes. Anyway, we've got a rocket that seems to be launched. It seems really to be ballistic, to use a bit of jargon. In other words, that it's just traveling under its own momentum. It's more like it isn't a rocket. It's more like it's something launched from a catapult. But let's not worry about that. This is what it is. So it's traveling up and up and up, getting slower as it goes up under the effect of gravity. You don't need to spend that amount of time thinking about all the implications. What I'm trying to do is to train you to understand these graphs. In an exam, obviously, you would move on to the questions a little sooner than this. Let's do that. Estimate from the graph how many seconds the rocket is more than 25 meters above the ground. Okay, already we're in more difficult territory than we were in the first question because we got to estimate. We're talking about it being more than a certain amount above the ground. So let's think about that. More than 25 meters above the ground. 25 meters is here. So let's find those points on the graph. We've got this point here, and we've got this point here. We don't need to use a ruler to draw across because we got that line. So the question is, how much time from this point to this point? So let's see where those lie on the time axis. Well, you can see that this here is pretty much halfway between these two lines, and we're estimating, so that's close enough. So that's about there. And this here is pretty much halfway between these two lines. We're estimating, so that's good enough. So we come down, so we are about here. So we've got the difference between 6 3/4 and 1 3/4, basically. So we've got 6 3/4 minus 1 3/4. Well, we can ignore the 3/4 is 6 minus 1 equals 5. So 5 seconds. I'm going to make more of a 5 and less of an S because we don't want it to be S. 5S. Okay, 5 seconds. And we're given S there, so we don't need to write the units. You can check this just if we just start at 2 and count to 7. 1, 2, 3, 4, 5. 5 seconds. There we are. Nice and straightforward. Estimate from the graph how far the rocket climbs between the times of 1 second and 2 seconds. Okay, let's rub out what I've got here because we want it to be clear. As we have established, between times of 1 second and 2 seconds. So 1 is here and 2 is there. How far does it climb between those two times? So 1 second, if we work up here, follow my cursor, we start here at this point, let's circle it. And 2, we get to this point, let's circle it. So, what heights are we talking about? Well, this here, let's get rid of the circle so we can see more clearly. It's kind of hard to see where that crosses. I think it's actually crossing just above the line there. So we got 15 to 20. Halfway would be 17.5. It's slightly more. Let's say that that is 18. And this here, so where are we here? I'm going to get rid of the circle just so you can see a little bit more clearly. I'll put a bigger circle actually, and that'll make life simpler. There we are. So we're going across, it's about here. Okay. So, this line here, halfway between 25 and 30, it's going to be 27.5. Is that 27? It's a bit less than 27. I think it's about 26.5. I think if you said 27, it'd be fine. But let's be as accurate as we can, you know, within reason. Within reason. So basically, we need the difference between 26.5 and 18. How do you find the difference between things? You subtract them. What was the top one? It was 26.5. So 26.5 minus 18 is, of course, 8.5. So about 8.5 meters. It says estimate. So we want to be reasonably accurate. but certainly to the nearest half metre is fine. I think that anything from about 8 to 9 metres would be marked as correct here. Anything outside that might get 1 mark, maybe if it's close. I suspect they'll say 1 mark for anything for 7.5 to 8 or for 9 to 9.5 and 2 marks if you're between 8 and 9. That's my guess for how this might be marked, but it does depend on the mark scheme. Make it as accurate as possible, which means as accurate as the graph reasonably allows. When you're looking at this point here, for example, I mean, is it 17.5? Is it 18? Is it somewhere between those? You can't read it that accurately. The lines are too thick for one thing. So, okay, and that's that for this question. Onwards and upwards. Quick glance at the comments to see what's going on. ABC, if your birthday month is January to August. Why January to August? Why not January to June? That'd be a more orthodox division. Ah, it's because you're thinking about which school year you're in. I see, I've got it. Fima says, can I agree with the answer? Or maybe it's can't I agree with your answer? And Fima's talking to someone called Khan. Who knows? I haven't been following the comments very closely because I've been concentrating on not embarrassing myself with the maths, as has happened before. It's good to see all the people who've joined the lesson since we started. If you missed the beginning, don't forget that you can always rewind to the start later and watch the early bits. And of course, my videos stay up on the channel, hopefully forever. In case I get banned for making too many mistakes. If you want to get a complete list of my videos, all the videos I've ever done for you to watch and enjoy, it's linked in the video description under the video on YouTube. Up there on Facebook, it's called it's something like go.easy11plus.org/video list. I think the URL is something like that. It's linked down there anyway. It's called video list. This graph, the graph shows how a freshly made cup of tea cools over time. Assuming that nobody drinks from it, in which case there will be some more rapid changes. Oh, this is inspiring me. I should drink some coffee. Oh, I need this. Yeah, my poor addled ancient brain needs all the help that it can get. Okay, speaking of which, I'll open out my answers for the rest of these just to make sure that either that I'm not making terrible mistakes, or that if I do make terrible mistakes, at least they're the same terrible mistakes that I made when I was frantically solving these questions in the 5 minutes before we started this lesson. Okay, freshly made cup of tea cooling over time, temperature here, time after tea has been made here, and it's interesting that the graph is kind of bobbly, not smooth. In other words, it has the look of a graph that's been made from real results with all the little errors and distortions that can happen when you take actual measurings in the real world, which is nice. It's a different kind of problem. It isn't idealized, which the other questions that we're looking at today all are, one way or another. So temperature, time after the tea has been made. There's no 0, but we can see if we count back, 3, 2, 1, 0, that this is 0. In other words, this is the point at which the tea is made. One could debate exactly what that means. What is the point at which the tea is made? Is it the point at which you start pouring the water into the mug? Is it the point when you finish pouring water into the mug? Is it the point when you put a thermometer in straight after stopping pouring tea into the mug? We could be picky, but interesting that it starts at 80 degrees, I think. You wouldn't, I mean, if you try to make a cup of proper Yorkshire tea at 80 degrees, then you can get the hell out of my house, because, yeah, we don't want to know about that. I reckon this is probably a cup of green tea, which you would make appropriately at 80 degrees Celsius. We should be doing some maths, shouldn't we? What is the temperature of the tea 1 minute after it has been made? Okay, 1 minute after it's been made, that's here. And we go up and we are here. And that is this point here. And I apologize for the fact that the lines on this graph are very, 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 very faint. But that's just an artifact of this paper being repeatedly reproduced, I think. Okay. So what is this temperature? So if we look up here, we have 20, 40, 60, 80. Okay, so it's 40, 50, 60, 70, 80. Next thing we ask ourselves, and you always go through this process to avoid making embarrassing mistakes, how many lines are there between each of these thick lines? And you can just about see, let's look over here because it's clear space, 1, 2, 3, 4, 5. Okay? So it's divided by 5. 10 divided by 5 is 2, so each of these lines represents a movement of 2. So I'm sorry, actually, these are faint on my screen here. I can see that in the stream here, they're incredibly faint. Something to do with my software, and I apologize for that. But this might be a really good time to open the worksheet that's linked in the video description. Open it in another window, and then you'll be able to see these lines rather more clearly than you can on this live stream. I can tell you that this is 3 lines above 60, so it's 66. 66, oops. Do we need to add units? No, it's there already. Degrees Celsius. Celsius or centigrade. Nobody can ever make up their minds. After how many minutes and seconds has... Someone says, how long is this? I feel your pain. And not that much longer. We're romping through. This is the middle question, but I think we're accelerating a bit as we move along, maybe. Yeah, it's only 20 past 6. I think we'll probably be another 15 minutes on these questions, I reckon, more or less. And then we'll look into the tip of the week, but I've forgotten to think of one. Maybe I'll think of one in the meantime, and taking a few of your questions, and then we'll be done. I've got no desire to go on extra long tonight either. I've got other much less important things to do, but they still need doing. After how many minutes and seconds has the tea temperature cooled to 45 degrees Celsius or centigrade? So let's find 45. Well, 50 is here. Always worth writing these things in so you don't make a horrible hash of it. So 45 is here. So we go across, and we are here. So I think that is exactly halfway between 4 and 5. I think that's 4.5 minutes. So I think that's 4 minutes, 30 seconds. Now, when you get a graph that is as vague and hard to read as this, you will get some latitude, because you might read across from here and be slightly higher or slightly lower. So I think anything between about 4 minutes 20 and 4 minutes 40 ought to be accepted here, and probably would be accepted according to the mark scheme. But obviously I don't have the mark scheme, so I can't tell you. But I think anything between 420 and 440 should be fine, because they're reasonable responses. How long does it take the tea to halve its original temperature? Give your answer in minutes and seconds. Halve its original temperature. So what is its original temperature? It's hard to know exactly, but I'm pretty sure it's supposed to be 80 degrees. So basically, when does it reach 40 degrees? So we're over here, aren't we? 40 degrees over here. That's where the line reaches that point. But where does it reach that point? Is it here? Is it here? Is it here? I don't know. The lines are too thick and too wibbly. So I am for two reasons. One, because it's simple and easy to read, and two, because it's the middle of those options, and so it's likely to be in the range that the examiner has in their mark scheme. I'm going to go for the point where it crosses this line here, which is here. And what is that? That's 5 minutes, and now we have to get a little bit fiddly. 5 minutes and 4 of the 5 dividing lines, so 5 and 4/5 minutes. If you write 5 and 4/5 minutes, you will lose a mark, because you are clearly being required to provide an answer in seconds. So we know it's 5 minutes and something. What is 4/5 of a minute? So a minute is how many seconds? 60. We want 4/5 of 60, which is 4/5. And remember, this is something I say very often in my lessons. Of becomes times, unless it's out of, in which case it becomes divide. 4/5 times, and 60 we can write as 60 over 1, because any whole number can be written as a fraction of itself over 1. And now we've got fractions multiplication. Remember, when you're doing multiplication of fractions, only when you're doing multiplications, not when you're doing addition, subtraction, or division, you can cancel diagonally, which is useful here because 5 and 60 cancel. How many times does 5 go into 60? It goes in 12 times. So 5 goes into 5 once, it goes into 60 12 times. So we got 4 times 12 over 1 times 1, which is 48 over 1, which equals 48. Okay, you could also do it as a decimal problem, so you could do 60 times 0.8. That would actually be my preferred way of doing it, but I said 4/5. I thought I would stick with it. 5 minutes, 48 seconds. Now, there's obviously going to be a bit of leeway here, but if we go with it being that line, then 48 seconds makes sense. And in fact, that is going to help us with the next question, because what is the temperature of the tea 3 minutes 48 seconds after it was made? Oh, we know how to find 48 seconds, don't we? 3 minutes and 48 seconds. It's this line here, which is here, which is here, more or less. Oops, I think that could be a bit more accurate. It's here. So it's pretty much that line there. So we got 40 and 1, 2, 3, 4 of the 5 dividing lines. So 40 and then 4/5 of the way to the 50, 48. Okay, so in fact 48 degrees C. So after 3 minutes 48 seconds after it was made, I've said after twice there, it has a temperature of 48 degrees centigrade or Celsius. There we are. Onwards. Quick glance at the comments, but I'm going to promise and then fail to keep my promise. Try not to get sidetracked. Very important penguin, who is indeed very important and also a penguin, wonders whether I'm going to do something special for my 100th live. Yes, definitely. I've got it all planned out. No, I haven't. I've got absolutely no idea, but I should do something. Maybe I'll just wear a silly hat. I don't know. That wouldn't be the worst thing if I wear a silly hat. Maybe I can get Dimitri to wear a silly hat. Okay, the graph shows the depth of water in Grandma's bath one evening. I like these questions. I find them quite interesting. Label each section of the graph with one of the following letters. Some letters may appear more than once on your graph. Interpret that to mean some letters should appear more than once on your graph. Just putting the right letter in one correct place will not get you all the marks. You have to put it everywhere where it applies. So I would recommend that you take a second to look at the graph and think about it before you start applying these things, because then you'll probably have worked out some of the things that you're going to need to label. So we got the depth of the bath in centimetres. It's a bit hard to read because they've covered it with a line. Terrible formatting, but what can you do? Some people don't know how to use computers. We've got time in minutes along here, goes at 20, 40, 60. And the depth, oops, this is very important to note, starts at 0 and so does the time. So at the starting point, there is no water in the bath and no time has elapsed. And in fact, that's why they've got the circle around it there. But it's important to understand that. So the bath starts filling. And then the depth increases. So for the first 10 seconds, it fills at this pace. 10 centimetres of water. It fills with 10 centimetres of water. And then for the next 10 seconds, it fills rather faster. So what might change there? Well, it could be that the bath is sloped at the bottom, and then as the water fills, it fills less quickly, and then the sides of the bath go straight up. But then I would expect this to be curved as it's filling that area, and gradually the water is going out more. I wouldn't expect a straight line. So this would only really work if it was kind of straight up and then straight up more narrowly. So yeah, if the bath went... Oh, and also, the bath would have to get narrower. Yeah, no, what I said doesn't make any sense at all. The bath would have to get narrower for this to be the case. For it to fill more rapidly, it would have to be like that, and then it would have to be like that. So that no bath is shaped like that I've ever seen. So why would it suddenly fill more quickly? Because she's turned up the taps, or she's turned on another tap, something like that. And then the bath... not suddenly, in the space of no time, between 20 seconds and 20 seconds, suddenly gets 10 centimetres deeper. How on earth could that happen? Does it mean she suddenly turned the taps up to the max? No, because there would still be a passage of time. It would just be as even steeper, like that. The only way that in effectively no time, although obviously it would take some time, the water would suddenly go up, would be if you suddenly put a large thing in it, possibly a grandma. And then the water level is flat for a while. So no water is flowing in or out, and grandma is sitting in the bath. Fairly self-explanatory. Then the depth goes up a bit. So she's already in the bath and the depth goes up. Well, it could be that she's brought her enormous rubber duck into the bath, and that's displaced water, as her own body did. But what do you notice? This steepness is exactly the same as this steepness. So it's probable that she's just running a tap again in the same way that she did at the very beginning. Then it's flat again, she sits in it a bit longer, and then she maybe goes, oh, this is getting a bit toasty, and well, if this was getting in, then this is presumably getting out. And then the water level drops rapidly, but not instantly. So this must be the water draining out of the bath. Now that's a really useful thought process. You know we're going to have to label these stages, and by thinking through it, we can now just tag the labels on where they want to go. Both the hot and the cold taps are running. A. Well, is there an option for not both taps running? Yes, it's E. So this first bit, only the hot tap is running, is going to be E. But careful, the same thing happens up here, the same gradient, so that's also going to be E. And therefore the point when both the taps are running, that must be here, A. And there aren't any other points where taps are running that we can see from the graph, so we're done with A and with E. Grandma gets into the bath, B. We spoke about that. That's here. It happens at this time point. You could also put the label, I suppose, above 20 seconds. Or you could put it here, I guess. Anywhere that makes it clear that you're referring to this line. That's when Grandma's getting into the bath. So we're done with that. Grandma takes the plug out. Okay, and in my notes, I've got an arrow by this saying, careful, because I needed to comment on this. Grandma takes the plug out. Lots of people will do this, which is incorrect. Why do you think that's incorrect? Because this is not the point when the plug is taken out. You've labelled this whole time when the water is draining out, but the plug has already been taken out at this point here. Because the plug being taken out is a moment in time. This is what happens after the plug has been taken out. So if you don't get that right, there's definitely a mark to be lost. I feel like that's sort of the sneaky moment in the question. Not unfair, but sneaky. It's testing your detailed understanding, not just your ability to whack labels on in generally correct places. Grandma sits in the bath reading her book. Ah, yes, that's clearly this. We spoke about it. But wait, it's also this. Now, those of you who are more mathematically minded may find this a little bit irritating because you'll say, how do we know when she's reading her book? Maybe here she's sitting in her bath not reading the book. Maybe she read the book, then she ran some hot, then she just lay there going, uh-oh, this is too hot, and then we don't know. But take the question on its own terms. Don't be too picky. Don't be a smart aleck, as the saying goes. What this is really saying is, when is she just sitting in the bath? The book is of course irrelevant. Grandma gets out of the bath, and that happens at this point here. And again, you could label above it, or you could label on the timeline. It doesn't really matter. And there we have it. We've labelled everything. That's it. I like this question. I think it's quite interesting. It makes you think, and it makes you think about how real life situations might be represented on a graph. It is not an accurate graph. It's, in maths, it's what you call a model. It takes real life and simplifies it. So, for example, baths don't go straight up and down. They're always curved. I've never seen a graph that wasn't, and that would distort the graph. Also, for example, Grandma is not going to teleport into the bath and suddenly be inside it and suddenly be outside it. Her getting in and out will take a period of time. So these lines here would be more complex things. They wouldn't just be boom, straight up, boom, straight down. There are various things of that sort, but we're not going to worry about those. It's a model. It simplifies reality. Okay, last question you'll be relieved to hear, especially whoever asked. Okay. Onwards. Sam says, who the heck reads a book in the bath? If I had a bath, I would read a book in the bath. I love reading in the bath. Unfortunately, I only have a shower. It's quite a nice shower. It's pretty powerful and, I'm very happy with it. But I would love to have a bath. And if I did, I would read in it. What could be nicer than reading in the bath? You can listen to a podcast in the bath, I guess, but then you're sort of nervous about putting your head underwater. If you read a book and it's not an expensive book and you don't mind it getting damp, then, Luxury, pure luxury. Try it sometime. Not with a signed first edition, but with a book that you enjoy reading and can afford to get damp. It could change your life and probably annoy everybody else who wants to get into the bathroom. Every evening Diana has a bath. Lucky her. She is the person I aspire to be. Yes, she is whom I aspire to be. She turns on the taps and waits patiently for the bath to fill before she turns them off and steps in. That's a very wordy way of saying that she doesn't get in the bath until she's run it, which is important because lots of people get into the bath and then run it a bit more. This is another simplified model of reality. At the end of her bath, she steps out of the water before pulling out the plug to empty the bath. And I think it's reasonable to assume that this is going to be one of those scenarios where she gets in and out of the bath instantly. And indeed, that seems to be the kind of thing that occurs. In fact, it doesn't matter because this is not measuring the height of water in the bath like the last one. If you can read that, if you can look closely and read it, it's a bit easier on the printed worksheet. It's linked in the video description. You'll see that this is about the volume of water, and her getting in and out doesn't materially change the volume of water, apart from a few sort of splashes that she might release, which don't really matter. It's the volume, not the height. And when she gets in, it displaces the height of the water upwards, but the actual volume of water remains the same. Okay? Something to think about. And here we got time in minutes. Okay? We got in litres, in minutes. Take note of that because those units could easily be important later. I might have inside information because I might conceivably have already looked at the worksheet, but it's a reasonable guess, isn't it? Right, so what happens? She turns on the taps, the bath fills at a steady rate, so unlike in the previous one, she doesn't fiddle with the taps, she just turns them both on and lets them do their thing. Then she's in the bath, all along here, and then she lets the water out and it drains at a steady rate. And this is another of those mysterious baths that only appear in maths exams that go dum, dum, and have no curvature. Conveniently, but unrealistically. How long does she spend in the bath? Well, we've established that she gets in straight after running the bath and gets out straight before. That's made clear by the question. So she gets in here, she gets out there. This is 25 minutes, this is 5 minutes. So, how long might that be? 25 minus 5 is 20. Lose a mark, everybody who wrote that, because there are no units given and the question does not say how many minutes. So we do not know. 20 might mean 20 years. For all that the marker can tell. 20 mins, or, because the question says minutes, why not write, and the graph does, why not write minutes? It won't cost you very much time. It's unlikely to waste the time that makes a difference between passing and failing. Work out the number of litres of water that flow into the bath per minute. Underlined and bold. Could there be any clearer? As the bath fills up. So what's the total? This is very hard to read, but if you look up, you've got 0, 250, 500, 750, 1,000. Ah, yes, 1,000. No, they've underlined it and put it in bold. The number of litres per minute. What does per mean? It means divided by. Why am I shouting? Because so many people will make this mistake in this question. And you don't want to be that person because you want to get the marks, because otherwise what are you doing sitting this exam? So we have 1,000 litres. We don't need the units at this stage. Divided by how many minutes? Because this magic line, of course, the fraction bar means per. 1,000 per 5 minutes. So 1,000 litres per 5 minutes. Well, we don't need to do a division here. You know this means 200 litres per 1 minute. Okay, 200. 1,000 over 5 is 200 over 1. 1,000 litres per 5 minutes is 200 litres per 1 minute. Yep. Got it. Fantastic. I've just robbed out my answer. I'm a fool, but we knew that anyway. 200. Now, here is where language and reality run up against maths exams and the people who mark them, who are not always specialists in English comprehension. The question says, work out the number of litres. So the units are already specified in the question. So logically, this is already a correct answer. What is the number of litres? The number is 200. But you may still encounter an examiner who says, there aren't any units, this is wrong. Logically, they're not correct, but they're the ones who decide. So please don't be that cocky person who goes, aha, I don't need to write this, just write it anyway. 200 litres. Does the bath empty at a faster, slower, or the same rate as it fills? Two ways to approach this. You can look at this line here, and you can say, well, we're losing 1,000 litres in 5 minutes. 1,000 divided by 5 equals blah, blah, blah. We know the answer, we just did it, it's 200. But look, this clearly isn't requiring working. You can answer this question, as mathematicians say, by inspection, which is a very fancy way of saying by just looking at the thing. And by just looking at the thing, we can see that this line and this line, they have the same steepness. They each go up to 1,000 across one section of the graph. It's clearly the same rate, just in reverse. So the answer is the same, or they clearly tell you what to write, same. And that's it. Ladies, gentlemen, etc., we have solved it. Our lives are complete. Swapna says, how much longer? I can hear the cry of pain behind Swapna's screen. So now on to the... And the tip of the week is when you're hosting a YouTube lesson and there's a regular tip of the week, don't forget to prepare one. Let's move on to... Kartik says, I am going to die. I'm assuming this is a comment on the entertainment value of this lesson. Poetic Tea says, at Julie, that was rude to tell him to shut up. I don't know who's been telling someone else to shut up. Okay, people, calm it, please, in the comments. Be nice. You shouldn't need me to tell you that. This is a public forum. Everyone can see these comments. If people get nasty in the comments, I end up having to delete the live chat from the video when it stays up on YouTube. And so your comments vanish forever, which is a shame. It's a real shame because you want your comments to be seen. I want them to be seen. They're an important sort of community for people to encounter on the channel. So please stop it. As someone says, there's a lot of beef in the comments. Why? For heaven's sakes, people will pick a fight over anything. This is a lesson about time graphs in 11 plus maths exams. What possible thing could there be to argue about? Goodness me. We're not debating the merits of Brexit or anything like that. Okay, any questions coming in? Kartik says, that was a really easy lesson. Do you have tricky lessons? I could feel the aggression pouring off from this comment. That's the beef that people were talking about. Yes, I do. I have some extremely tricky lessons. I really mix it up. In fact, the comprehension that I was doing for the last 2 weeks was very hard. I've done some very hard maths in the past. 2 ways for you to approach it. Kartik, because it is, for all that I'm laughing about it, it's a perfectly reasonable question. Happy birthday to AAA Star Driving School, by the way. Your 9th birthday, good to see you, before that comment vanishes. 2 ways for you to approach it, Kartik. One is to go to the channel homepage on YouTube. So just click on the channel icon below this video, but not until I've finished, and you'll go to the channel homepage, and you'll see the various playlists there. And there's a playlist dedicated to harder maths. I actually put this in that, but I might move it to the core maths playlist because I kind of agree with you. Yeah, go there and you'll find harder maths. What more can I say? If you go to the core maths playlist, you'll find easier maths. If you want to find harder comprehension, then some questions, some lessons make clear in the title they're advanced or whatever, and blah, blah, blah. There isn't an easy and advanced separation for creative writing because creative writing is creative writing. How easy it is depends on how adventurous you are, really. So yeah, there's lots that's harder. The other thing you can do, I said there were 2 things, linked in the video description is, I referred to it earlier, my video list, which is literally just a Word document that I keep updated that you can access online, and it lists all my videos with links to all of them, and then you can find all my lessons. And in the name of each video, it says whether it's advanced maths or core maths and blah, blah, blah. So just look through it. They're in order. They're not grouped by topic. They're listed in order. But on that list, you can find everything. The meaning of life. 42. Right. Nicole says, if you're under pressure, how long should you spend on a hard question before you miss it out. My neighbour just across the road outside the window is called Nicole, but I'm assuming this is a different one. But yeah, how long should you spend on the question before you miss it out? Possibly the same Nicole, possibly a different one. I'd phrase it differently because there isn't really a direct answer to this. What I would say is if you're spending time working through it and you're doing things that are building towards the answer, then it's probably worth your while to continue because you've done all that work and you may as well carry on. The difficulty comes at the point where you're just staring at the page. If you're just staring at the page, you're not doing anything constructive. And at that point, then probably you should just move on to the next question and come back to it later and see if you get more inspiration. Because obviously there's that first point I always talk about where the question's difficult, but you just start by writing down what you know, not staring at it. And then you start trying to do things with it. But if you get to a point where I'm just staring, I just can't find any way through this. Every extra minute you spend staring is a minute you're not going to have time for. Is a minute you're not going to have for answering other questions. That's what I meant to say. I've been on this lesson too long. I really have. I should end soon. I've been doing shorter lessons recently. It's good. Let's keep this one quite short too. Let's not head up towards an hour. So yeah, as soon as you're staring, move on, basically, because that's the bad time. How do you work quickly but accurately in the exam under time pressure? You want me to give you magic tips, but to be honest, it's mainly about practice. And the best way you can practice is initially to work without time pressure, to get really good strategies, really solid methods for approaching all kinds of questions, and then doing time practice once the exam is quite near. And just doing that steady build-up, going through the steps of preparation so that when you're in the exam, you have the skills already. It's not all new, and then you can just work through steadily. But don't panic if some things hold you up. If you do find yourself staring at the page a bit, it's normal. Just be brutal about moving on. Can we see Dimitri? It's a bit hard in the summer because he always goes out to sit on the balcony, and so he's kind of, across the living room, down the hall, through the kitchen. It's pretty much all one big room here. There's only one door apart from the toilets, which is to the spare room, which is a little bit difficult when you've got cats. But anyway, yeah, he's out there on the balcony, I think. So alas, I can't really grab him without disappearing off. Maybe not. Swapna says, wow, this lesson has really helped me. Oh, that's lovely. You were begging for it to end. That's really kind that you have found something useful. I'm going to finish soon because I really want to finish. I can't give you a better reason than that. I'm tired. It's the end of the day. I've got light shining on me. It's hot outside. I can't take this much longer. But Robert, I get a lot right on papers without time, but I spend hours. What should I do? I've talked about this a lot on this channel. If you're spending hours, it's probably not because you're consistently spending hours across the paper. That wouldn't be a normal thing. What's almost certainly happening is that there are certain things that hold you up. And so the main thing you need to do is next time you do a paper, identify very clearly and write notes on your paper to record it, next to the relevant questions, what it is that's holding you up. And I don't just mean which questions are holding you up. I mean, which thought processes are you getting stuck on? Which kinds of words in questions are causing you to get lost? Which topics? And identify these things. And then practice those kinds of questions. Think carefully about the wording. Practice those topics. And then come back to a similar paper and do it again. And now see where you're getting held up. So identify the sticking points and practice addressing the sticking points. And that is the best way that you can improve your speed. Good question. What equipment would you use to measure accurately on a time graph? A ruler, basically, to draw across from the line to the edge. But there's only so accurate that you can be because you're constrained by the thickness of the lines and the accuracy of the data that went into composing the graph. So be reasonable about it. In none of these graphs that we've been looking at are they expecting you to say, 18.262. It's always down to the nearest half something at best, by and large. Not always, so minutes and seconds. You could get to whole seconds if it's 4/5 of a minute, and that's 48 seconds. But, common sense applies. Okay, I'm going to pick one more question. I'm sorry for the ones I've missed, but I'm losing it if I hadn't lost it already. People asking about specific schools, I tend not to answer that because it doesn't apply to everyone on the channel. I'm sure you can understand. Loads of people asking about Queen Elizabeth School. I don't think they publish past papers, which makes it difficult for me to do a video lesson on, I'm afraid. Because I don't have any resources to base school-specific lesson on. However, there are loads of my lessons here that are really similar to the format of their exams. And you know enough about their exams from the sample resources they share to go out and find those lessons on the channel. What are you planning on teaching yet? Please tell. Also, do you make other videos? If so, what kind? Have a look at my video list that I've referred to find all my videos. What am I planning on teaching yet? Next, I have absolutely no idea. I haven't planned it yet, sorry. I should do some reasoning because I haven't done it for ages, but I tend to avoid it because I find it really boring, so I'm kind of torn. Maybe I'll do some writing. I should probably do some reasoning, to be honest. I'm not sure. I think it's probably going to be reasoning or writing. Those are the most likely things. Robert, what happened to the yellow panda mug? Nothing in particular. It's just sitting in the kitchen cupboard. Or maybe... No, it's on top of the dishwasher because I used it earlier. Yeah, you're right. This is a bad choice of mug because it kind of... It blends too much with the background. You're right. I didn't choose it for the colour coordination. I just picked up the mug I was drinking from anyway. A clanging mistake. A clamorous error, as the Italians would say. Right, okay. I think that'll do for now. I'm just rambling nonsense. So, the music starts, the audience fades, the children crawl away to their beds, or their computer games, or to kicking their younger siblings. Don't do that, be nice. It's been lovely to have you here. It's been a beautiful lesson. It's been beautiful. And I look forward to seeing you next Tuesday evening at 6 o'clock for the next Easy 11 Plus live lesson on something. I have no idea what, as I just said, except maybe probably reluctantly reasoning, which I'm sure you love, but I don't especially. Right, don't forget my free marking offer. You can send me your work for completely free feedback. If you haven't done that, why haven't you? It's an amazing opportunity. You can get comments from me, celebrity input on your work. Anyway, have a look at the offer. I'm going to link it in the comments right after this lesson. And if you're impatient to see the offer, just go to the 11 Plus Lifeline webpage. You can Google it. You know how Google works. And the offer is linked in a banner across the top of the page, so you can't miss it. All right, everybody. It's been fantastic to have you. Bye-bye. Bye-bye. And then Robert dreamed of sitting in his bath and reading his book. But he can't. Because he has no bath. And if he did, it would have curved sides, so it wouldn't be compatible with an 11 Plus model of a bath. And, oh dear, it's time to end this